Hello everybody, it is time for us to look at the 6-6 worksheet about conditions of special parallelograms. Kind of goes along with 6-5, but kind of the converses of the theorems we learned in 6-5. Number 12, Becky is asked to classify PQRS. What is her error? So she says PR bisects opposite angles, SPQ and QRS. So PQRS must be a rhombus. However, it bisects the angles in such a way that this angle and this angle are different, and angle QPR and QRP are different. And so that is something that we can't use. If it bisects and makes the same angle here and here, then we could say it's a rhombus. So how do we write that? We say, in order to be a rhombus, both diagonals have to bisect opposite angles. In order to be a rhombus, both diagonals have to bisect opposite angles. And also, the opposite angles of this are not congruent, so it's not even a parallelogram. These opposite angles are not congruent, so this is not, not even a parallelogram. All right, number 14, write a proof to show that if ABCD is a parallelogram and angle ABE is congruent to angle BAE, then ABCD is a rectangle. So I went about this with a paragraph proof, and I started by using the isosceles triangle theorem. Because if this angle and this angle are congruent, then AE and EB will have to be congruent. So BE is congruent to AE by the isosceles triangle theorem. And since this is a parallelogram, we know that the diagonals bisect one another. So if I know that AE is a certain length, then I know that CE is the same length. And I know if BE is a certain length, then DE is a certain length. So what I can say there is DE is congruent to BE, DE is congruent to BE, and CE is congruent to AE, not CA, whoops. CE is congruent to AE because the diagonals of a parallelogram bisect one another. All right, and that means that if we add together those two pieces, AE and CE, they are going to be the same as the two pieces DE and BE added together. So I can say that BD is congruent to AC, and that adding together would make this by the segment addition postulate. By the segment addition postulate. Which means, since the diagonals are congruent, that this is a rectangle. So we can say ABCD is a rectangle because diagonals of a rectangle are congruent. There we go. We've proven that this is, in fact, a rectangle by using the diagonals. Up here, we've got a higher order thinking question, which are always kind of fun. The longer diagonal of a rhombus is 3 times the length of the shorter diagonal. If the shorter diagonal is x, what expression gives the perimeter of the rhombus? So let's first of all draw this rhombus. Let's see how well I can do here. Okay, so it says the longer diagonal is 3 times the length of the shorter diagonal. So this diagonal is the longer one, so we might call it 3x. And then this diagonal, the shorter one, we could call it x. But of course, it gets divided in half. So I'm going to write each of these as like their actual halves here. So I have half of an x as a 0.5x. So that short one should be like a 0.5x. And half of the longer one, half of 3x, is 1.5x. So the short diagonal is 0.5x on each side. The longer diagonal is 1.5x. If I'm trying to find the perimeter of a rhombus, I want to try and find the third side of one of the right triangles that makes up the rhombus. So I'm going to want to take the Pythagorean theorem with those two side lengths that I know. 0.5x squared plus 1.5x squared equals our hypotenuse squared. So 0.5x squared is 0.25x squared. 1.5x squared is 2.25x squared equals c squared. There's going to be some variables in our answer here. So we put these together, we get 2.5x squared equals c squared. And then we can go ahead and take the square root of both of these. So the square root of 2.5x squared has two parts. The square root of x squared is just an x, so that can come out of the square root. The square root of 2.5 is a bad decimal, so I'm just going to leave it underneath the square root. So I'm going to call the square root of 2.5x squared x root 2.5. So then we could also say, if you did this as a decimal, you could say 1.58x equals c. So both of those will work. If you used x root 2.5, there are 4 sides of x root 2.5 in this rhombus. 2.5. So that means that the perimeter is 4x root 2.5. Or, so that's equal to the perimeter. If we did 1.58x as each side length, then we would just multiply that by 4, which would be 6.32x. So either way, 4x root 2.5 or 6.32x. There we go. Number 19, what is the perimeter of parallelogram WXYZ? So another one where we're going to have to use some Pythagorean theorem. If I have the parallelogram here, I know that the diagonals bisect each other, which means that they cross right at the midpoint here of this line. So instead of a 24, we can divide this into 12 and 12. And we have a diagonal with a length of 13 here. So what I can do is I can use this little piece to find half the height, so I can find the whole height of this rectangle and find its perimeter. So I can use the Pythagorean theorem to find that small piece, say x squared plus 12 squared equals hypotenuse 13 squared. And when you solve this out, you get x equals 5. It's actually what we call a Pythagorean triple, because 5, 12, and 13 are all whole numbers that work in the Pythagorean theorem. So this is 5, which means the entire height is double of that, or 10. So when we add up to find the perimeter, all we have to do is 10 plus 10 plus 24 plus 24, altogether gives us a perimeter of 68 units. And there we go. Numbers 20 and 21, determine the name that best describes each figure. These are really important for us to understand. So number 20, we have one pair of sides that is both parallel and congruent, which means this is automatically a parallelogram. And we have these angles that get bisected by diagonals, which only happens in a, happens in a few different places, but it happens in rectangles and it happens in rhombuses, although what we can see is that all four of these are all exactly the same. So we can tell that these are 90-degree angles because the angles, when split up, split into 4 even parts. And if these angles are supplementary and they split into 4 even parts, then each of them is 45 degrees, which makes these 90-degree angles. So if we have a parallelogram with 90-degree angles, and it's a rhombus because these are divided exactly in half, this has to be a square. All of those things are true. In this example, number 21, we see we have these alternate interior angles that are congruent, which means the top side and the bottom side have to be parallel to each other. We also see these 2 arc angles, which are congruent. That's another pair of alternate interior angles that this time means the left side and the right side must be parallel to one another. So the clues here tell us that this is a parallelogram because it has 2 pairs of parallel sides. And it doesn't have anything else either. It just has 2 pairs of parallel sides. Number 22, give the condition required for each figure to be the specified shape. Well, if we want this to be a rectangle, we want the diagonals to be congruent and the halves of the diagonals to be congruent. So we want to say that means that 3x minus 1 will equal x plus 13. We'll solve that. X equals 7. So the condition required for this to be a rectangle is that x is 7. Same thing down here, we want to do similar. This condition required to specify that 23 is a rhombus is that this angle is going to need to be 90 degrees because the angles in a rhombus cross, or the diagonals in a rhombus cross at 90-degree angles. So 6x plus 6 equals 90 degrees. Solve the equation. X equals 84 divided by 6, which is 14. So x would need to be equal to 14 here. Number 24, we've got 3x plus 12 on one side and 5x minus 24 on the other. We know that the diagonals of a rhombus bisect the angles of a rhombus, so these need to be the same. So 3x plus 12 equals 5x minus 24, and we'll solve this. Divide by 2, and we find that x equals 18. There we go. Number 25, Melissa charges $1.50 per square meter for laying sod. She says she can compute the amount to charge for the pentagonal lawn by evaluating the expression 1.5 times 12 squared plus 0.25 times 12 squared. Do you agree or not? So obviously, $1.50 per square meter, that's what we're multiplying this entire expression by. So that means we need to figure out whether the area of this shape can be computed by 12 squared plus a quarter of 12 squared. And if this shape has 2 pairs of parallel sides and it has diagonals that are, well, it'll have diagonals that are bisected because it's a parallelogram. and it has pieces of the diagonal that are congruent, so that tells us it has congruent diagonals. It also has right-angled or perpendicular diagonals, which means it's a rhombus. So this is a square. So if one side is 12, the other side is 12. So I know that the large shape can be found by 12 squared. And then we can see that, hey, these two triangles down here, they happen to be congruent. That's one way to think about this. We have another square down here. That's another way to think about this, which is, oh, it's a rectangle, but I know that this piece and this piece are the same as this piece and this piece. So I know that this is a quarter, 0.25 of 12 squared. So it's another quarter of our shape. So yes, we'll say yes, because the perpendicular diagonals and it's a parallelogram and congruent diagonals make it a square, three things. So perpendicular diagonals, congruent diagonals, and actually, let me think. I think that might be all we need. If the diagonals are perpendicular and they are congruent, makes it a square. Makes this a square with a quarter of a square added to the side. With a quarter of a square added to the side. All right, 29, parallelogram ABCD has diagonals with lengths AC is 7x plus 6 and BD equals 9x minus 2. For which value of x is ABCD a rectangle? Well, we're going to need to solve the equation to make those diagonals congruent to one another. So 6 equals 2x minus 2. 8 equals 2x, which means x equals 4, which makes B the answer there. Up here, after knitting a blanket, Monisha washes and stretches it out to the correct size and shape. Opposite sides line up with the edges of a rectangular table. So we know that those tables' edges are parallel. She plans to sew a ribbon around the edge of the blanket. How much ribbon will she need? So this question can be answered two different ways, depending on whether you use 58 inches as half the diagonal or 58 inches as the entire diagonal. Really, 58 inches should be the entire diagonal here, but I understand if you are thinking about it in different terms. So what we can do is we can do this kind of two different ways. We can say, all right, she plans to put a ribbon around the blanket. This appears to be a parallelogram since the edges of a rectangular table will be parallel, which means the diagonals will bisect one another. So either the diagonals are each 58 units long or they are 58 plus 58 or 116 units long. So if we do it this way, we can make a right triangle like this to find the dimensions of the missing side. So we can say 42 squared plus x squared, the side we don't know, equals 116 squared. That would be the length of one diagonal. So that's 1,764 plus x squared equals 13,456. Then solve. Okay, the other option, the other possibility is you thought 58 was the entire length of the diagonal. So in that case, that would be 42 squared plus x squared equals 58 squared. So that would be 1,764 plus x squared equals 3,364. Solve. get 1600. And then we take the square root of both of those, and we get x equals 40. All right, so either way, either x equals 108 or x equals 40. If x equals 108, when we find the perimeter of the blanket, we'll do 2 times 42 plus 2 times 108, and that's going to give us 300 units. Or if we think that x, the other side length, is 40, that means that we can say that we have two side lengths that are 42. Let me get red here. Two side lengths that are 42 plus two side lengths that are 40, which means the perimeter is 164 units. So either or would work here. Let me write or in big letters. So you can have either one of these methods for solving. Number 28, are the terms below valid classifications for the figure? Select yes or no. So we want to know whether it's a square. Well, a square is going to need to be a parallelogram. It looks like this is a parallelogram. It's going to need to have perpendicular diagonals. This one does. And it's going to need to have congruent diagonals. But that's not marked on here. So we're going to have to say no, we don't know, because we don't see congruent diagonals marked. Is it a rhombus? Well, if it's a rhombus, it's going to have perpendicular diagonals, and it's going to be a parallelogram. This is a parallelogram. It has perpendicular diagonals. So yes, this is a rhombus. Is it a parallelogram? It is. We've said that a couple times already. Is it a rectangle? If it's a rectangle, it's going to need to be a parallelogram with with congruent diagonals. But we don't know anything about those diagonals, so we don't know that it's a rectangle. And then if it is a trapezoid, it's going to have one pair of parallel sides. This one happens to have two pairs of parallel sides. So we also need to know if it is a trapezoid, it's going to have congruent diagonals, at least if it's an isosceles trapezoid. So this is not a trapezoid either. And there are your answers for this worksheet. Let me know if you've got any questions, and have a wonderful day.